everybody, and welcome back to our packet sniffer. So basically what we are going to do now is continue analyzing our IP header. So let me open up our terminal, and in the previous video we started off by actually importing the first line of the function. So let us navigate to Python programs and to the network, or how did we call it? Let me just check it out. Packet sniffer. Yeah, very creative. And let us nano our sniffpackets.py. Let me enlarge this so everything is good to see. And you can see right here that what we did for now on is, first of all, it's not HRD, it should be HDR for header. And what we did for now on is use the struct unpack on the 20 bytes, which is the actual amount of bytes that the IP header has. So basically we saw the available fields in our Scapio library once again, and all we have to do right now is unpack those fields. Now some of you actually asked a question, now what does this mean right here? So we used it both in this program right here, and we also used it when we actually extracted the source MAC address and the destination MAC address from the previous section. Now basically this is just us splitting these 20 bytes into different parts with our struct library in order to actually be able to more easily split different fields in the IP header. For example, once we used here 6S, this first 6S corresponded to the destination MAC address, so we split it and we used that 6S in this function right here. The second 6S was actually another 6 bytes, which basically corresponded to the source MAC address, and this capital H corresponds to the remaining 2 bytes, which was the actual protocol that we printed out right here. Or basically we printed out all of these 3 fields right here. So basically what we did, we split the ether header into 3 fields, and we actually corresponded it to this pattern right here. So same we will do right here, but if you notice that let me just open our IP header, has a lot more actual fields than the actual Ethernet header. What we need to do is actually use some of those fields. So let me just lsip. You can see it has a bunch of these fields such as version, IHL, TOS, which is basically the type of service, which is not really that important, but you can see that this, for example, version right here has 4 bits, and basically what we can do is just put these 3 into one actual field and then split it up by the bytes, or pardon me, by the bits. So we can try to do something like that. You can see it has a lot more than the previous actual Ethernet header. So we also have the source and destination IP address, which we know from the previous videos, it should be in the IP header, time to live, some different flags, and the length, ID, and so on. So we will have to actually add all of those fields. So let us nano sniffpackets.py, and let us continue with the first field, which is the version field. So in order to actually represent the version field, we can just type ver, or ver, equals IP underscore header, and we use the first part that we split with the struct unpack command, which will be the first H, which will correspond to the first 2 bytes, I believe. And then what we need to do is correspondence is the version, since first 3 fields of the IP header we will actually place in the one variable, or not in the one variable, but we will actually split it as if it was a one variable, and first 12 and the version we want to actually arrow to the 12, which represents the 12 bits. Now it will remove the other fields from the version variable, and it will shift this version variable 12 bits in order for us to actually get just the version itself and not other fields as well. We are doing this because some of these fields are a lot smaller than the others. For example, in the Ethernet header we didn't have to do that, since actual destination and source MAC address corresponded to the entire 6S part right here. So we didn't have to actually add it to anywhere, and here we actually do have to do that. The next field that we actually want to print out would be the IHL, which will also be the part of the first split part of the IP header, and we can also add it like this, so IP underscore header 0. which responds to the first element of our list that we created with this command right here. Now what we want to do is arrow it to the 8, but not only arrow it to the 8, we want to use a logical expression with this sign right here, which basically ends, and we want to add a byte 0x0f. Now the reason why we are doing this, but first of all let me just put this in the actual bracket, since we need to have the brackets while ending this. Why we are doing this is basically it will take the data from our IP header variable without the version. So we know that the version is actual first field in the IP header and the IHL is the second field in the IP header. So basically if we were to shift everything, we would take the both first fields in that actual variable. But since we already have the version, we do not want to have it once again attached to this variable right here. We will end it in order to lose both the field before and the field after the IHL field. So the next one that will be the last part of the first element will be the actual toss, or if you want to, type of service. Now, as we said before, first three fields belong to the first stage, so this will be the last one. Let me just add it right here, equals IP header, so IP underscore header, the actual first element, which we specify with this 0 in the brackets, and all we have to do is end it with the amount of bytes or bits that we actually have. Oops, not this. I don't want the brackets, we want 0x00ff, which is basically, since this is the last element of our first element in the IP header variable or list, or however you want to call it, we don't really need to do this type of thing right here, since this was the element in the middle, so we actually had to perform some additional logic expressions. Now, if you don't really understand this, basically you can just search logical expressions in Python. It is just some bit and byte manipulation, so nothing really too hard, but for you it might be new. But as I said in the previous videos, this will be one of the more harder programs, if not the hardest programs in this course that we are actually coding. Now, for those of you wondering where did I get this program for, I actually searched it up, and it is actually on the Cybery IT. So there is the example of this program also coded and tested, so you can actually check it out there if you want to. It might actually give even a better and more detailed explanation for those of you who are actually wondering how this is all made. So the next thing we want to actually put right here is the total length of the actual packet. So we will just put that in the entire second element. We're just specifying the 1 in the square brackets, since this will correspond to the entire H right here. So tot length once again stands for total length, and the next one will be the IP ID. We can call it like this. This is the ID field in the IP packet, or IP header, and it will correspond to the entire actual third, or representing the 2 in the square brackets element. Then after that we have something called flags and flag or frag offset, however you want to call it. Let me just check it out in Scapy if I said the name correctly. I believe I did, but it's always good to double check everything you're not sure of, since we as hackers don't really need to know everything about coding. Basically that's what I said in the beginning of the course. We are not coders, we do not care about the actual code being well written. All we want to do is for our code to be actually good and able to run. So you can see I was right, the flags and the frag are the next two fields. We can see the bit field 13 bits and the bit and the flags field 3 bits. So what we will do is we will actually use this to our advantage, and since we can see that flags only get 3 bits, we will have to shift it 13 to the right. Let me just double check everything here. Okay, we can exit the Scapy. So we are approximately halfway to our IP packet. Oops, not sniff jokes, sniff packets, but nano sniff packets. And let us add the actual flags variable. Okay, so we will call it just flags equals IP underscore header. the third or fourth element in our list shifted 13 bits. So the next thing that will also correspond to the fourth element will be the frag offset. So frag underscore offset equals IP underscore header, third element, and we want to add it to the amount of bits needed. So let me just find the actual, okay, so here it is, 0x1FFF. Now, I'm not really sure if this would actually work with the binary, but don't try it. I didn't really try it. If you would specify binary, I don't think it will actually work, since there is not really a library that will run the binary itself, or that will read the binary itself. I might be wrong, but if you want to, you can actually try the binary instead. So just specifying the hexadecimal values into bits, or into basically zeros and ones. So next thing we want to specify right here would be the time to live. So IP underscore TTL, which stands for time to live, would be the IP underscore header. Fourth or fifth element, however you want to call it, this is the fifth element in the IP header list. And we want to move it 8 bits. Now, since that is not the only actual field that we will use in the fifth element, we also have the IP protocol. Did I just type 8? Okay, so here it is. IP underscore proto will be equal to the actual IP underscore header, and then the fourth or fifth element once again, and we use the same sign for the logical expression 0x00ff. Now, for those of you wondering where I am getting this information from, well, basically, if you want to check out the headers themselves, you can just go onto your Firefox and just type the IP header and see what are the available fields and how many amount of space or memory they actually take. So basically, we know that the entire IP header takes 20, but different fields actually take different amounts, so you need to check that out. IP header structure, maybe we can try something like that, so we can check out the structure of the IP header. We could have done the same with the Ethernet header, but Ethernet header was rather simple, or simpler than the actual IP header. So here it is. As you can see, here is the picture that actually might explain a little bit better for you, or you might be able to understand it in greater detail. So if only it actually opened the picture, IP header format. That is too small to see. Let me just find if they have a little bit of bigger picture. Maybe this is something useful. Not really. Let me go and find maybe this one. Okay, so you should be able to see something right here. As you can see, if I open up the actual program, so you can see the first field, for example, you can see that we actually use the version IHL and TOS as a first actual field that we split with this command. And we can see the version, the header length, and the service type are actually the first three fields, which we actually counted as one while splitting. Then we actually had to do some byte or bit manipulation, logical expressions, in order to get them to in order to get these variables right here to only contain the information from that specific field. Then, for example, the total length was entire one field that we split, so we didn't have to actually do anything with it. We just set that to be equal to the second element in the IP header variable. And afterwards we continued with all other things as well. So we are currently right now, let me just see, we finished time to live, here is the protocol, and the header checksum. You can actually you can realize that it will actually be the same amount of memory or the same amount of size as the total length. So what we will be doing is we will only use the element from this list, the entire element, to represent the header checksum. So we don't need to do any byte manipulation, or pardon me, bit manipulation. We can call this checksum equals IP underscore header and the sixth element. So this is actually everything we have to do for the checksum. Now, The next thing which we need to specify is the source IP address and the actual destination IP address. So you can see that it actually takes double the size of the actual, for example, header checksum, and what we represent with this destination and source IP address in this command right here is this 4S and 4S. So one 4S will be the actual source, since that is the first one, so source address will be equal to the socket.inet_ntoa. Now this function will allow us to actually parse the IP address so we can actually print it later on. So all we have to specify in the brackets of this function. Now before I do any of that, let me just show you, for example, once you encounter some function that you don't know, all you have to do is actually just type socket.inet_ntoa in the Google search bar. We're finding that site. Okay, so not www, we just want to search the actual function. Let us actually go to Google, and then from Google we will search, since for example, since this is actually not working, not really sure why, so socket.inet. Oh yeah, so I didn't really actually want to search since it had dot, it actually thought it was a website. So you can see it is low level networking interface, and that function, if you just scroll down, let me just find the name of the function itself. These are a bunch of the functions that are used for the socket programming, so anything you don't really understand or need more detailed explanation, of course not even I, or basically I don't think anyone normal would know all of these functions, since there's too much of them. Now you can know, for example, what some of them represent, but there is really no point in learning all of this. So here it is, inet_ntoa, it says convert a 32-bit packed IPv4 address to its standard dotted quad string representation. So since this is an actual representation of the IP address that we usually see, we want to be able to print this as a string, so that's why we convert it. So in the brackets it takes an input of the actual IP address, which we can specify if we look like here, if we look right here as the 6th element, or pardon me, 7th element, but in the brackets we will specify the number 6, and that's all we need to do for the source address. The same we can specify for the destination IP address, so equals socket.inet_ntoa IP_header, and we specify number 7 in the square brackets, 7, and close the brackets here. Now the last two, which is the options and embedding, we will not cover, so basically we will skip those. All we want to do from this part right here is actually extract the data from the IP header. So let me just enlarge this right now, since we don't really need a picture at the moment. You can see we specify 20 to be the size of the IP header, as well as 14 to be size of the Ethernet header. But once we actually printed all the information, or basically extracted all the information from the Ethernet header, you can see we actually stripped the data from the Ethernet header. So then it processed the data to the IP header without the Ethernet header. Now once we actually parse all the fields we need from the IP header, we can actually extract the IP header from the data in order to continue analyzing the packet further on. So in order to do that, we will just perform the same we did in the Ethernet header. So from ._receive, we want to strip from the 20th byte further on, and that we will store in the data. So we don't need to specify 34, since the first 14 have already been stripped from the data in the previous function. So everything should be good to go. All we have to do right now is actually print all of the stuff that our IP header has. So let us see what we can do if we go down here and we print same thing we printed right here. So let us actually keep the size to be the same, which really will not work, but it doesn't matter. We can just add it like this and change the Ethernet header to be equal to the IP header. So we print that, so we know that these next fields will be from the IP header, and we will use the version 2 dots, the same %HU as in the Ethernet header that we used, I believe. Okay, so we did use it, to print these statements. So let me just add the actual space right here and %var, which is our version variable. Now we need to do the same for each actual variable. So IHL, we just type all of this in, so you should type it as well. Make sure to specify the correct name of all the variables so our program doesn't really crash. We need to specify this right here. Oops. Where is the %? Okay, so here it is. HU from the toss variable. Then we print the length from the total length variable, I believe. So, okay, we did call it like that. Print the next field, which is the ID field. Now this will take a little bit of time, so I will just skip until I write all of these fields. Okay, so here it is, everything is printed out, but before I continue, make sure to double check everything and make sure that the destination and the source IP address don't have the %HU, that they have the %S, so we can actually print the string. Now the reason for that is because of this function right here. As I showed you before, what this function does is it will turn the IP address into the printable string of the IP address separated by these dots. As you know, the IP address format is something like this. So this is the IP address, and this function will basically make this a string, so we are printing, so what we are printing is an actual string. That's why we have the %S. All we have to do right now is, since at the beginning, or not at the beginning, what we want to do is actually check, since down here we specified the actual function to retrieve the data receive and the TCP UDP, and if you check in our function, we really don't have anywhere anything named TCP_UDP, so we actually have to check whether this IP header has a TCP or UDP header attached to it, or if it even has some other header. But what we are mostly interested in would be a TCP or UDP header, which we will extract further on. So in order to check what the header is attached to this IP header, we can actually use this variable right here, which is IPProto, which will contain the value of the next protocol that will be in actual packet. So in order to check what the TCP and what the UDP header numbers are, you can just go to here and go somewhere right here, and TCP protocol number. You can just type that in the Google search bar, for example. You can see that the actual transmission control protocol, or the TCP, is actually number 6. So you can just go down here. You can go list or not port numbers. We're not interested in the port numbers. That doesn't even matter. We saw that it is an actual 6. List of IP protocol numbers. This is actually more useful to us. I don't know why I clicked on this. So list of IP protocol numbers, and you can see TCP is under the number 6. If you go down here, you will find UDP under the number 17. So those are two numbers that we actually have to watch, and we need to specify them in our function. So if the IPProto variable contains number 6, that means that the TCP header is attached to the IP protocol header. To the IP header, and if 17 is in actual IPProto variable, that means we have a UDP header. So if IP_proto equals to 6, TCP_UDP variable will be equal to the string of TCP. Else if IP_proto equals to 17, what we want to do is that TCP_UDP variable to be equal to UDP. And else, for any other case, since those are not the only two protocols available to be specified in the IP header, we need to type the TCP UDP to be equal to other. Now this other will specify any other packet that this might actually contain, and all we want to do is return the data which is data stripped from the IP header, and the TCP_UDP variable. And that would be about it basically for this IP header. We extracted everything, we printed everything, we checked for the actual TCP and UDP protocol, whether they are specified in the IP_proto variable, and then we return the data and the TCP_UDP. And then right here, what we will do in the next video, we will actually check whether we got the TCP or UDP, and then we will continue as we need. For example, if we got a TCP, we will extract it to the analyze TCP header. If we got a UDP, we will extract it to the analyze UDP header function. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye.